Hello dear students, how are you all? So in this अबे यार मुझे कुछ बोलना ही नहीं आ रहा. This is very much awkward because I'm doing it after a long time recording on your studio. So well, congratulations for those who succeeded this time in Neet exam, and best of luck for those who are going to write down the next year exams. So as we know that the competition level of exam is increasing day by day, and the political fiasco that is going on in India. So keeping all this in mind, as a teacher I would like to suggest you that your future and everything is in your hands now. You have to work extremely hard to beat any competition, even though paper leaks and all that they will keep on happening because of this corrupt government that we have. No offense, Modi ji. With this, let's start this discussion on Biot Savart Law. So we are going to start the magnetism chapter, and the first concept in magnetism is Biot Savart Law. So we have Biot Savart Law in magnetism. Okay. So Biot Savart Law, it basically gives the value of magnetic field. Why we use it? It gives the value of magnetic field. Due to what? Magnetic field due to current carrying wire. Due to current carrying wire. So we know that if there is a wire which is having current in it, if we have a wire having current in it, a wire carrying current I in it, around this wire there will be magnetic field present. Okay, from needle deflection experiment, iron filling experiment, class 10th, we have seen that the compass, the magnetic compass, shows deflection when placed near the current carrying wire. It means that in the region around the current carrying wire there is a presence of what? Magnetic field. Okay, so magnetic field is present around the current carrying wire. So how much is the value of the magnetic field? That is decided by, that is given by our Biot Savart law. Okay, so let's say that it is a current element DL. A small element of the wire is DL. It is carrying I current. I current is going on in the wire, and a small element is DL. So what we can say that? We can say that magnetic field at point whose position vector from DL is R vector. This is point P, position vector from DL is R vector, and the angle between them is theta. Okay, so the angle between them is theta. So we can say that magnetic field at this point P will be proportional to current element. So magnetic field will be proportional to current element, that is I DL. Okay, and not only DL but current element which is perpendicular to this radius vector, position vector. So if the angle between them is theta, DL vector is making angle theta with the R vector. So if I talk about perpendicular to that R vector, so how much will component will come? Current element will be IDL sin theta. Okay, next point is dB is proportional to 1 by R square, inverse proportional to distance square. So if you combine both of them, magnetic field will be proportional to I dl sin theta divided by R square. Okay, I dl sin theta divided by R square. Now if you replace this proportionality with an equality, so proportionality will go equality, here comes constant comes mu naught by 4 pi. So mu naught by 4 pi I dl sin theta by R square. So this is our elemental form of Biot Savart law. So very important law. From here we can do a lot of derivations for circle, for wire, straight wire, finite, infinite wire, on the axis of the circle, like that. Okay, so this is Biot Savart law. And one more point, if you are talking about in vector form, so vector form of Biot Savart law will become dB vector equals to mu naught I upon 4 pi DL vector. Two vectors are there, DL vector and R vector. Since sin theta is coming, between them sin theta is coming, so we'll take the cross product of these two vectors divided by mod r cube. This is the vector form of Biot Savart law. Mu naught I upon 4 pi dl cross r divided by mod r cube. Okay. Now one important point is there. Here dB, you can see that it is 1 by r cube. So dB vector proportional to 1 by r cube. So does it follow inverse square law or inverse cube law? So the confusion can be there because it is cube. So students might think that it is inverse cube, but since we have defined it in vector form, r already we have taken here. So there already we have a mod r, because r vector will have two things, mod r and r cap. So we have here r vector in the numerator. So that mod r will get cancelled. So even though it is coming r cube, but it does not follow inverse cube law. It follows what? Inverse square law. Okay. So using this Biot Savart law, we can define the value of magnetic field for different cases. Example, we can define for circle on the axis. We can define at the center of circle. We can define it for finite wire, magnetic field due to finite wire, or we can define it for magnetic field due to infinite wire, or various other cases we can define. We can define it for thick wires also. Multiple cases can be given where we can use Biot Savart law in integral form or differential form, and then from there we can solve it. Okay. Next derivation we'll see in the next videos.